Okay, so who's up first? I don't have any of the sheets in front of me. What number? Number 7? All right. No, this is review set unit 2. All right, I'm gonna be honest with you. Part A says do the molecular, complete ionic, and net ionic. I'm only doing the net ionic. I'm not worried about the other two things. Using solution stoichiometry to determine the LR, determine the ER, determine the concentration of the excess ions remaining, and then the mass of the precipitate produced. All right, Justin, if you can come back and get this. All right, so the first thing we're going to do is the net ionic equation. Now, based on just looking at this, and I think I talked to some of you, if you know it's a precipitate reaction, it's a lot easier to work this thing backwards than it is to work it forward. So I'm going to go ahead and work it backwards. Based on this double replacement reaction, what is going to be your precipitate? Okay, that is your precipitate. All right, everybody cool with that? So that tells me that what has to be the ions that perform that? Okay, there's a problem. It needs to be balanced. So I need 2 and I need 3. We good so far? Okay. All right. So now the first part says determine the limiting reaction. So Dustin, I agree with you. This is kind of a little challenging because it does not give you a volume. So we're going to assume that it is 1 liter. We're going to just assume that it is 1 liter. Okay. I will be honest with you, there will never, ever, ever be a problem like that. That's something you have to assume. Don't ever have that fear. They will give you every bit of that. All right? Okay? Now, so that does make it a little bit easier to say because all of these molarities can now be turned into what? Moles. That's going to make it much simpler. Okay? All right? So now we have to divide those two things by 2. So has anyone already divided the 0.054 by 2? What is it? All right, because since it's divided by 1 liter. No, it's not divided by 1 liter. It's multiplied by 1 liter. Because moles is molarity times volume. Okay. What is it one more time? 0 point. Like that? Okay. All right, and then this is what, 0.29? All right, so now we can determine which one our LR is, right? Okay, so part 1, that's easy. There's our LR, actually wrong color. This is our LR, and what's our ER? There's our ER. That is these two numbers right here have been divided by the coefficient. This right here is the identifier. Identifier. So real quick, hang on. What we did, we started with the initial given up there in black. We said assume it's in 1 liter. Okay. So what we did is we did volume times molarity, which is the number of moles, right? Since it was assumed that it was 1 liter, these molarities just turned into our number of moles. Okay. Then these purple numbers are the number of moles divided by the coefficients. Okay, so that's our identifiers. Does that help you, Nicole? Okay, so these numbers really don't mean anything other than helping us identify what our LR and our ER is. Yes, ma'am? It's not going to change anything. It's the same thing. It's the same thing. Okay. All right, I'm going to do part D next. Part D says identify the amount of solid produced, right? Okay. So I'm going to do this one first. It's a little bit simpler. Say that again? Yeah, sure. Because, I mean, really, that's technically what's limiting it is the iron. I mean, Jamila, that's a good point. technically, what is limiting this reaction from making any more solid? The iron 3 ion. So technically, that is the limiting reactant. Okay. It doesn't, but it does. Specifically, it's iron 3. Categorically, it's the iron 3 bromide. You like that? Well, bromide is just going to hang out no matter what. It can't. It's the compound. Okay. All right. Now, my question is, this is the important question. Which one do I convert from the reactants to the needed product? Now, which one is that one? The iron 3, that was my question. Which value do I use? Very good. Again, this in the purple is just an identifier. We don't need it. So 0.05400 moles of Fe3+. All right, so I'm in moles. What's my first step? Okay, so moles to moles. So I've got Fe2CO3, and then Fe3+, and what is it? Okay, it is 1/2. And then the hard part again, if you got to find the mass, it's a pain in your butt. All right, and so you got moles, and then you got grams, and we know what we're going to, so I'm just going to leave those off because I'm being lazy. And so what is the molar mass of iron 3 carbonate? 291.73. I'm pausing. I mean, this is a mole to gram step. This should be very basic. The hardest part is knowing what the mass is. That is the longest part of this entire problem. I think you would all agree with that. That is the longest part. The iron 3 carbonate. The one thing that I will say about the AP exam that I've seen trending in the right direction. Now again, don't come back to me on May 1st and throw something at me because it's not true. Again, I've said it's trending that way, that I've noticed a lot of times they want you to do stoichiometry. They give you the mass of the compounds. Again, it's not always, but I've noticed a trend. And simply because, do you agree that if you mess that mass up, it's going to give you an error in your calculation? And that's not really fair, because if you know how to do the steps, then I don't think it's fair to take points off just because you may have pulled in the wrong numbers somewhere. Again, it is chemistry, it is math, it is a part of it. But I would much rather you be able to do the stoichiometry than screw up the mass and mess up the whole problem. Okay? All right, so what was the mass of the solid you should have gotten? All right, so let's pause before we go any farther. The two numbers up here on the top are your givens. 4 significant figures is what you should have. So what is it? I hear like 9 numbers coming at me. Okay, grams of Fe2CO3. Okay. All right. So that was the easy part. Part C is probably the one y'all read and you say, I don't know how to do that. Oh no. What does the question say? So it'll be after it's mixed. Yes. All right, so is everybody good on this one? All right, so part number 2 says part C. Find the concentration of the excess reactant. Well, same thing. Yeah, because it's the ion, right? Okay, it's the same thing. So find the concentration of the excess reactant, which again is going to be the ion. So here's your steps. So step number 1 is convert the LR to the ER. Okay, convert the LR to the ER. Step number 2 is the original moles of the ER minus used moles of the ER, and this is going to give you your moles of ER remaining. Okay, and then there's one final part. The reason you cannot stop here is because what was the question? Calculate the concentration. Okay, this is the part where it gets really weird. So 3 we know is going to be moles over liters, right? But the problem is that this is after the reaction has occurred. So you took solution A and solution B and you did what with them? You poured them together. So you've got a total volume to deal with. That's the complicated part. Okay, because you have to consider that the concentration, should it increase or decrease because of the added volume? It should decrease. It should drop it a little bit. Okay, it should drop it a little bit. All right, what part's your question? Question 1. All right, so let's go back and let's look. All right, so we have, what's wrong? Let me go back. What do you mean, can we just do it? That's what we're fixing to do. Yeah, we're going to go back and do it. All right, so we've got, the first step said convert LR to ER, right? All right, so our LR was 0.05400 moles of Fe3+, right? So I'm going to the moles of my ER, which was carbonate. Okay, so what's going to be your over-under? 3/2. Okay. Do you agree that I started with 0.0875 moles of carbonate ion? Okay. What I'm doing now is trying to determine how much I used. Okay. So anybody got that number? 0.081. Give me 2 more significant figures there. 0, 0. Yeah. Exactly. Nope. And the reason why you don't go to grams is because what was the final question? You're trying to find concentration. In concentration, you need moles and you need liters. Leave everything else alone. Yes, we're still assuming liters is 1. Hold on, hold that thought. All right. So what I just found, that's not the right button. Oh my gosh. What I just found was my used, which is 0.08100 moles. How much did I start with? Okay. So that's going to tell me how much I have left floating around. Because when I say used, where did those used ions go? What was one of the products? What's the product that you see it in? Where did that carbonate go? It went into this thing, which is what? It went into the solid. So when I say used, it technically precipitated out. They're no longer floating around. They're no longer hanging out in the solution. All right, so this is 0.00650 moles, which is exactly what you do, which is you divide this by 2. 0.00650 moles divided by 2 liters. Now, the reason it's 2 is because what I said a minute ago. You took solution A, solution B, what'd you do? You poured them together. So that makes your volume double. Now, what if it would have been 2.5 liters of each? Now, obviously, all your mole stuff would have changed, but what would you be dividing by? Dividing by 5. Okay, so you have to account for the change in the total volume when you pour these two things together, because this is important. We're trying to find the number of moles of excess remaining, right? And when it says remaining, that means you had to get rid of some of it. Well, where did that some of it go? It turned into the solid. It precipitated out. Very good test preparation. It's for everything. It's for everything, yes. Okay? All right. Go ahead. Well, but carbonate is CO3 2 minus. Where did the 3 come from? But that's only in the solid. We're specifically looking at the ions in the solution. Okay, it's a good question, but we're only looking at it in solution. All right, so what would this be? Okay, 0.00325, and that's molarity of the carbonate ion. Now, Trevor, this is something you were asking about a minute ago. Is that 100% acceptable? By all means, yes. However, if you wanted to, you could say 3.250 times 10 to the negative third. That is 100% acceptable. Okay? Moles per liter? Is that what you're asking? It would be the carbonate ion. It would be the carbonate ion, yes. No, it would be the ion in this case, which is the carbonate ion. Yep. CO3 2 negative. Okay. This one is 4. It's 4. Alright. Any questions on this? Any questions? We're fixing to move on. This is your last chance. Any questions? All right. Mason, go ahead. All right. Write the reaction equations, net ionic, for the reaction between solid lithium carbonate. Just put it on my keyboard, please. All right. So solid Li2CO3, and again, that's solid. So do we ever bust solids? Leave it alone. And hydroiodic acid, strong or weak? So what do you write? H plus. Okay. Why did I write just H plus? It's strong, so you write the ion. Very good. Medicines used to treat bowel disorders are composed largely of lithium carbonate. If the tablet has a mass of, and it tells you it is 0.200 grams, and 92.5 milligrams of gas are produced, what is the percent of the medicine if composed of lithium carbonate? Okay, we've worked one just like this one. My first question is, what is going to be your other side? There you go. Yep. Not for this test, but that's something that you need to know in the future. And again, that's just the small stuff. Yep. All right, it tells you there was how many grams of gas made? Yep, it's the only thing that can be a gas, right? Okay. All right, I wish I had kept that longer. I need to re-see that again. I hope you didn't put that in. All right, so I don't even remember what the question was. All right, what percent of the medicine is composed of lithium carbonate? All right, this is a good one. I actually like this one. So this is the mass of the tablet, right? Now, the question specifically says what is the what? Percent. We know that percent is what? It doesn't get any more simpler than this. Part over whole times 100. What are we trying to find specifically? It says, what is the percent is if the medicine is composed of lithium carbonate? So, do we know either one of these yet? Do we know the part or the whole yet? We know the whole, and the whole is going to be 0.20 grams. All right, so that's the whole. The key is we've got to find the part. Now, so do you agree that of our two data pieces, we've already used one of them? Okay, so technically, I'm trying to find the mass of that stuff, right? All right, well, what do I need to get to this if I don't have it? What do I have to use to get there? What am I stoiching? I've got to go from my mass of my gas to my mass of my solid. Nicole, are you with me at all? All right, again, think about this. How many pieces of data do you have remaining you haven't used? One. You've got to use that one piece of data. If it is not in the right formula, what do you have to do to get it to the right formula? You got to do stoichiometry. And what's the only way to get from one thing to something completely different? Mole to mole. Now, the one thing about this problem, this is kind of like, I'm going to kick you in the teeth. No. Well, that obviously we got to do that first. It's what? Say it again. Milligrams. We hate milligrams. So if I want to get rid of this, let's go ahead and get rid of it. So how can I convert this into grams? Left three places. So 0.0925 grams. Okay, let's go ahead and get rid of the milli. We don't like those. Now, let's balance this sucker, and let's see if this is going to make any sense to us. That's balanced, right? You're right. It doesn't weigh in, but it's always good to make sure that just in case everything works out the way we want it to. So now it's balanced. All right. So let's take what we know and let's go with it. So I've got 0.0925 grams of CO2. Does anybody remember the mass of CO2? Look at you go. Remember a long time ago when I said you don't ever have to memorize them, but you will because just out of necessity? I wasn't kidding. Normally I hear people memorize carbon dioxide, calcium carbonate, and sodium chloride. Those are the three that I hear most often. Calcium carbonate's 100 even. That's why people memorize it. Yeah, NaOH is another one I hear people memorize a lot. Hydrochloric acid, that's an easy one. Alright, I just got really lazy right there. All I did was put S for the lithium carbonate solid, sorry. I know, that's kind of pathetic, but it is what it is. It is, but I'm just too lazy to finish right now. Go ahead. All right, let me ask you something. You remember the whole bottom line of this question is we're trying to find the percentage of that tablet that I'm intending to make you feel better. What percent of that tablet is made up of lithium chloride or lithium carbonate, right? They tell you that the tablet weighs how much? 0.2 grams. Well, if I'm doing part over whole, do my units have to match? So I have to have grams over grams. You know what would have been the best news is? Had they said that tablet is 0.2 moles. That would have made it one step shorter. Okay? All right. So what is your mole to mole ratio in this problem? 1 to 1. And does anyone know the mass of lithium carbonate? 70? 770? That's what the S stands for. The S is lithium carbonate. Solid. Do what? Sorry, Trevor. Now, I'm going to do the lazy thing again, and I'm going to take my mass, and I'm going to go ahead and plug it in up here at the part. If you want to write it down twice, that's fine, so you can see where the numbers come from and go. All right, what is the mass then produced of lithium carbonate? 0.155 grams. Now, this is where you can stop and take a double check. Should the mass of the solid be less than the mass of the tablet? Should the mass of the solid be less than... The tablet's the whole thing. Okay. All right. So should the mass of the lithium carbonate be less than the mass of the entire tablet itself? Absolutely, because that wouldn't make sense because it's a part of the tablet. That's why we do part over whole. So when you do this times 100, what percentage did you guys get? 78%. If you go 77.5, that's grand. That's 3 sig figs. I'm just playing into the whole number decimal. Does not matter. Me personally, I have always done percentages as whole numbers. I don't care. I've never heard of a rule on percentages. Of CaCO3? Or, excuse me, of that? No, that's fine. Sir. Alright, but when you pour it into water, it dissolves. But it can be a solid. Does that make sense? Because think about it. If I take that lithium carbonate solution, which means it's mixed with water, and I boil off the water, what's left? That stuff. Does that kind of make sense? So you can make it a solid, but when you mix it with water, it will dissolve. Does that help? Okay. All right. Is everyone good with this one? With this one? Okay. Everybody good with this? All right, Zava, bring it up here. Y'all feel like you're getting better at this? All right, so this one is stoichiometry, day 20, number 6. It says calculate the mass in grams of the precipitate form when 4.433. All right, I'm just going to kind of jot it down and we'll fix it how we need it. So it says 4.33 liters of Fe hate acetate. This is day 20, number 6. All right, there's a lot in this question. There's a lot in this question. Whew. All right, I know I did write it kind of weird. So the first of the question says, what is the mass of the precipitate if all this stuff reacts? So let's start there. Let's start with the balanced reaction. We'll plug everything else in. So what would be your precipitate if these two solutions were mixed together? Iron 2 hydroxide. Because if you look at it, what do we know about all acetates? Soluble. What do we know about all ammoniums? Alright, so that leaves us with Fe2 plus OH minus yields FeOH2. So our question is how many grams of that stuff do we need? How much do we have? Go ahead. You good? Yeah. Okay. All right. All right. It will in just a second. All right. It says that you have 4.33 liters and a density of 1.008 grams per cubic centimeter. Ooh. Wow. This is... We're just starting. Slow down, dude. Alright, here's why this is a tough problem. Is they give you a lot here. Bottom line, let's start with the minimum expectation here. The whole part where it says the total volume is 4.33, ignore that. Okay, just completely ignore that. The the issue is, what are we trying to find? What is the question? The mass of the precipitate, right? The grams of the iron 2 hydroxide. Well, here's the problem. Which one of the two reactants do I take to get over there? I got to find the limiting reactant. Now, let's start with the easy one first. We know that limiting reactant stands for what? Moles divided by a coefficient. Now, my first question is this thing balanced? Nope. I need a 2 right there. Now it's balanced. Now, normally, when they give you a volume and a concentration, you should be cheering for joy because that's great, that's wonderful, that's spectacular. But in this case, that's not the case. Okay. So let's start with the grams part first because we know how to do that one first. So let's start with the grams. Okay. All right. So we've got. See, this is why I don't like this problem. No. But I still think I want to go through it. And here's why. Let me ask you something. Can you calculate the mass of that thing? No, it's an ion. But can you calculate the mass of that thing? Yes. Help me out. Do me a favor. In the problem, does it tell you ammonium hydroxide is a solid? It's not a very quality question because of that fact. They tell you, just stay with me. Stay with me. Stay with me. Here's the deal. We've got to find the number of moles of ammonium hydroxide. So you can't find a mass of an ion. So you have to find the mass of the compound the ion is a part of. What is the compound hydroxide is a part of? Ammonium hydroxide. I understand that. That's because it wasn't given to you in grams. It was given to you in concentration and volume. That's why this is important. You have to, if it's grams, you got to use the whole compound. That's why I don't like this problem. All right, so we've got grams, we've got moles. Dustin, you have the mass of that? Thank you. Okay. All right. Thank you. Making sure you're paying attention. I did that on purpose. $35 point what? Thank you. Y'all are going to give me the right answer no matter what. All right, so this is the moles of ammonium hydroxide, which will be what? What's your answer here? 12.1? 12.2? Now, what are we going to divide that by to determine our identifier? Divided by the coefficient, which is 2, which is 5.99, right? That's right. What am I doing? My bad, I'm being an idiot. 6.05. Okay. Now, we found one of our identifiers. This is the part where it's going to get a little frisky. Dustin, I'm bouncing this off of you. What did you do with the liters in the density? All right. So here we go. Stay with me. All right. So here's the deal. They give you density and they give you volume. Can we utilize those two things to get to mass? And then can we go from mass to grams? Here's the problem. The density is 0.008 grams per cubic centimeter. Yes, 1.008. Nope. Hang on. Let me do this and I'll answer any questions you have. So here's the deal. They give you the density. That's easy. The volume they give you is 4.33 liters. If I go over here and I plug in 4.33 liters, why is it wrong? Your volume units will not match. Cubic centimeters is equivalent to a milliliter, which is 0.00433 milliliters. That's why this is a little fuzzy. I moved it 3 places to the left. This, if you had used the 4.33, it would have been wrong. Okay? So either way, now you can get grams. 0.00433. Yeah, that's right. 3 places to the left. I'm an idiot. Might be. That better? That's significantly different. Significantly different. My apologies. Give me my mass, please. Yes. Is that gram? Like that? That's grams. What's the compound? I hate acetate. No. I will know that if it says acetate. I just hope you don't think it's actinium, iron 2 actinium. It's number 89. Yep. All right. Now, this is the aggravating part. I should have never done this, but I'm too far in it now. Okay. Now, this is the fun part. Chance, do you already have the mass of that thing? Does anybody have the mass of iron 2 acetate? What is it? Oh, wow, we're almost out of time. All right, well, guys, here's the deal. I'm gonna pause. I'm gonna let you guys do this. Find your number of moles, find your LR, and then convert LR to the grams. You should be able to do it from that point. Okay, Trevor. Next question. Bring it to me. All right, listen. This is day 20. The other sheet. This is acids and bases. Nitric acid, strong or weak? What do you write? H plus is added to barium hydroxide, strong or weak? What do you write? So what's going to be your product? Water. Okay. Then it tells you had 0.2. Now, this should make sense. I mean, just kind of stay with me. So it's 0.222 liters. What did I do there? Very good. Then it was 0.2220 liters of the hydroxide, and it was 2.75 molar. Okay? So then it says, what is the concentration of the excess ions left in this solution? You got to find the limiting reactant. So literally what you do is you come back to this thing right here, and it's almost the exact same thing. It literally is the exact same process. Okay, well first we got to find the LR. Yes, ma'am. She's on her way. I'm eating lunch. All right, guys, I'm fixing to throw you a huge curveball. Hold on for the ride. The original, listen, the original formula was barium hydroxide, right? Remember, a long time ago, we learned that the concentration of the ion was the concentration of the compound times the what? Subscript. So, that is not the concentration of the hydroxide ion. 5.50. Because for every one barium hydroxide, you have how many hydroxides? Two. So the concentration should double, which automatically makes who the limiting reactant? The hydrogen ion. Yep. Okay, so that's kind of what's going on here. So again, you would take the moles, and again you can plug numbers in. It's the moles of the hydrogen ion, and we're going to go to moles of H plus to moles of OH minus, which should be equivalent, right? Because it's a 1-to-1. And then, well, you guys get it. It's the exact same as earlier. Here, Trevor. Yeah, 6th or 7th they're testing.